Hey guys, AP here, and today we are going to be continuing our Lightweight Java Game Library 3 tutorial series. So now in this tutorial series, we're actually going to start using textures for images, for the mesh. So right now, we have ourselves a sort of rainbow rectangle, which is pretty cool, but it's not really useful, because say you want to put like a texture of your face on this, you can't really do that, or you can do that, but you just have to define for every single pixel that you want it, which is not really a good idea. So instead of doing that way, like I said, which is a stupid way of doing it, you can just implement textures, which needs a few things. First of all, you need some way to actually load the information into a buffer, and then you need to get that buffer into the shader, and then you need to determine how each like each piece of information in the buffer determines what color is in each pixel of the mesh. So let's get started. So the first thing we're going to do is we're actually going to get a new library for texture loading. Now we do have STB, which is another way of loading images in Lightweight Java Game Library 3. However, it doesn't really allow for class path loading, which if you remember in the shader tutorial, if I go to File Utils, is how we can do it, is how we did it here. This should be file utils, not class. So file utils.class.getResource_stream. This allows us to not only work in a not jar method, aka in the Eclipse workspace, but in a jars, so you can actually put the shaders into a jar file and it still runs as normal. But so now what we're going to do is we're actually going to create, actually not create them yet. We're actually going to get another library in here. Now, if you go down into the description below, you get a link to the library we're going to be using, which I just have right here, which is going to be called SlickUtil 3. Now, SlickUtil 3 was in Lightweight Java Game Library, but it was in the second version, which is a pretty good version if you aren't familiar with GLFW. But as you can see, this was last modified about 4 years ago, 4 years ago, and it's just a couple that. So it's kind of outdated. It uses Java 8 still, so it's not really outdated. It's just that no one really works with it anymore. So it's not really used, and so that's why Lightweight Java Game Library 3 replaced it with STB, but it's still a pretty good library, so I'm going to use it. So in the description, there's a download to my GitHub. You can just get it there. But so yeah, so right here, we're not supposed to actually run it, but nothing happened, I think. I accidentally clicked it. So to actually add this is going to be quite similar to how we added the first libraries. Oh, the first libraries in here. So if we go here, we have to right click on our project file. Then we have add libraries. Go to your Lightweight Java Game library, which you can click on user libraries, and now you can edit it. So we're going to add external jars, and right here, because I was ready for it, we're going to add wherever you put your SlickUtil 3 jar. So if you click on that, as you can see, you'll have all these jars, and then you'll have the new SlickUtil jar. So close all that out. You don't need any more. You just need to add that specific one. So the next thing we have to do is we actually got to create a way to load the image. And with SlickUtils, it's actually a one line. It's pretty easy. So to do that, we're going to go into our graphics package and create a new class called material. What this material class will do is it will basically hold all the information about the texture, whether or not it has a color offset, whether or not it's shiny or not, whether or not it has a UV stuff. Like, it's basically like a Unity material, except in a Java class. So the first thing we got to do is we actually got to load the texture, like I said before. So to do that, we can do material. And this material is going to take in a path to that class, and then we actually need to load it in here. So the next thing we gotta do is we gotta create ourselves a texture, and we gotta create a slick util texture. So texture, and when we import it, you can use Control-Shift-O, Control-Shift-O. Control-Shift-O. Okay, there it is. Had to save that, I guess. So now you have org.newDon.slickopenGL texture. And you also have the test lightweight Java game library X, which is in there in the slick util jar. You don't need that. You just need the newdon.slick one. So if we do that now, we should see that we have ourselves a texture, and we can actually set something to that texture in our constructor. So in here, we're going to add another class called Texture Loader. And this is actually a class in Slick Util, and it basically, the only job it does is to actually load the texture. And so we have a bunch of get texture functions, which is load the texture. But we are going to use the one that says string format input stream in int filter. So just click on that. And so here is what we're going to do. So I'm going to actually explain what these parameters do. So the format is basically what is the file extension of the image. Usually I would be using PNG images, but since I'm not going to hard code that in, because maybe we need to use a JPEG or like a different, like a GIF file, I might actually make this dependent on the path. So to do that, we need to actually split the path into the two parts it is, the name of the file and the extension of the file. So to do that, we need the path string, and then we need to split it. So path.split, and then we need to actually tell what the splitter is, which basically splits up the string based on that character. So say we have like a URL right here. I'm just gonna put up a random URL, and we're gonna say dot split, and then whatever it is, which I'm just gonna probably do slash. As you can see, it'll separate up into array where the slashes are gone, but you have several strings based on where the slash was. And so this is actually a string, but it's a specific type of string called a regular expression. So what a regular expression is basically a one-line way of how to define several characters. So right now we only going to separate by one, which is the dot, because most files has the name, a dot, and then its extension. So to actually do that, we need these square brackets to indicate that is a regular expression, and then we need to put our characters that we're going to split by, which is, well, the dot. That's not what we're doing. And so finally, since this is actually returning an array, because you get multiple strings from this, we only want the last one, which is going to be 1, because there's only a name and an extension. So now we should get like a PNG, a JPEG, or whatever file image this is. So finally, going on to our next argument, we need to actually describe where we're getting this image from. Now we could just do like say new file, but like I said before, we want to do it where we want to do it off the class path. So actually we can just copy this, because it's actually the same, except the class name is a bit different. So what we need to do is, since it says file utils, we're going to use material, and then just get rid of this import. We don't need that. Oop. Boom. So there we go. This basically tells us where is our image in the file system. And so the final argument, which is the filter, I'll describe it when we actually get our image displayed. For right now, we're just going to use gl11.gl linear. Linear, there it is. And so now we got ourselves a texture loader. We also need to surround this in a try-catch, because what if it's not found? So in here, we are just going to say system.error.println, and then it's probably gonna just do whatever error handling you need to do here, but I'm just gonna say can't find texture at, and then whatever the path is. So path. And that is our image created, or loaded in. It's not created yet. Actually, it is created, because that's what the texture loaded class does. It creates the texture, and then actually binds it in the OpenGL. So we don't have to actually do any OpenGL code in this class, because the texture loader class does that all for you. So we're going to create a new function called a create, which is basically getting all of our information into the material class, and also for later on when we have all the shiny stuff and all the color offset stuff. But we're just going to have some basic information like the width and the height, and we're also going to have the texture ID. So this is actually a float, and then the texture ID is going to be an integer, so texture ID. And so with all that, we can actually set it in here. We can say the width is equal to texture.getWidth, and then the height is equal to texture.getHeight, and then the texture ID is equal to, well, the get texture ID, texture.get texture ID. And so that's all the create function is doing for right now. It's just creating the function. So we're gonna have a destroy function for cleaning up. So public void destroy, and that's basically telling OpenGL to get rid of the stuff at the texture ID. So GL 15, or not 15, it's 13. GL, and let that load. Delete textures, and then it's whatever our texture ID is. So now, for right now, it should be pretty good. Now we're having some getters and setters here because for the get ID, that's going to be useful for rendering, and then for width and height, that's just useful in general. So select getters, and there we go. So that's our material class done for now. I'm going to come back to it later, like for color offsetting and shiny stuff, like I said before, but the material class is good for right now. So now that we have ourselves a way to get the texture, we actually need to bind the texture to the shaders. So to do that, we need to go into our mesh class, and we need to bind some texture coordinates. Now what a texture coordinate is it basically is a way to figure out the bounds of a texture. So I'm going to put up a little diagram right here. Okay, so there's just a little bug, so I'm here from the future to explain it. The problem is that the texture, here are the bounds, so 0, 0, 1, 0, 0, 1, and 1, 1. So those are the bounds of the images, and you see the bounds of the rectangle or the mesh or whatever it is. And what you're trying to do is you're trying to map those textures to the other textures, or to the other mesh. And so when you do that, you're going to have a little skewed out rectangle, but that's because of the perspective and it's all wrong. So that can be fixed easily with matrices, but that's how texture coordinates basically work. So now that we have done explaining the texture coordinates, let's actually implement them. So similar to how we did the position and the color data, we are going to go into our vertex class, and we're going to get some information in here. So in the vertex class, we can't really use a vector 3f because textures are 2D, images are 2D, so there's not really a z component. So we're actually going to create a new class in our maths package called vector 2f. It's very similar to the vector 3f, except it has 2 values instead of 3. It's going to have an xy instead of an xyz. So that means we have to have a private float xy, public vector 2f, float x, float y. This dot x is equal to x. This dot y is equal to y. And then let's get some getters and setters. Oop, that's supposed to be float. Alright, so source generate getters and setters, select all, generate. So there we go. That is our vector2f class done for now. Like I said, math in a later tutorial, but for just these type of purposes, we're going to use them for storage. So now we're going to go back to our vertex, and we're actually going to add that into our vertex class. So private vector2f, we're just going to call it texture chords, or texture chord because there's only one. So we're going to import vector2f, and we're going to actually take that, and we are going to add that on to our little vertex. So we're going to say texture chord. This dot texture chord is equal to texture chord, and then we need to get texture chord. So boom, source, wrong one. Boom, source, generate getters and setters. And then we need to say generate getters for that one. So now with that, the vertex class is done. We can close that out. We can also close out the vector2f, and now we can actually bind it to our vertex array object. So to do that, it's quite similar to how we've been doing it before, except it's going to take up a different vertex or different indices, and instead of being 3 bits of information long, it's actually 2. So just change anywhere where you see 3 to 2. So 2, 2, 2. We don't even need the Z component anymore, so just get rid of that. And since it's a new vertex or buffer object, we need to give it a new index. So 2, and then of course it's too long, so 2. And now we can change some information about it. So instead of a color buffer, it's going to be a texture buffer. Same here, texture. Take that, turn all these into the correct ones. Color buffer is there. Color buffer's there. Instead of a CBO, it is a TBO. So put that up here, TBO. And so we go down here now to our destroy and just say delete TBO. So GL15.gl delete buffers. Excuse me. And TBO. And then we also need to get TBO. So public int get TBO. Return TBO. Okay, so that is it. We have ourselves error here. I guess there's just no error. So now texture buffer or texture information is now going to be in the shaders. Oh wait, we also need to say get texture right here, texture chord. That would have been a little mishap. That would have been a little weird. So there we go. That should be everything for here. So now that we actually bind it to the shader, we can actually use the shader. We can use the information in the shaders. So let's go to our shaders, and we'll also see a little error in main. That's because we haven't got any texture coordinates in. So we're going to go into the vertex because this is where our attributes are. And the first thing we're going to do is we're going to update our shaders. For right now, we have version 3.30, or version 3.3 technically. And we are actually going to update it to the newest version, which is 4.6 or 460. So in the last tutorial when I said shaders, I said that that's the version I'm used to. If there's any differences, I'll fix them. There really isn't any differences. They use the same keywords. They use all the same things. They just add more stuff to it that we're going to use later on. So what it does, it also knows where the location is based on order of lines. So 3, it knows that this is 0 because it comes first, and the next, and the next. So now this order matters, but then that's the only difference basically. So now we can say in vec2, and what are we going to call it? We're going to call this a texture chord because that's what we called it before. So now we need to pass these texture coordinates on to our fragment shader. I'm just going to open that up. And so we're going to do the same thing we did for color. We're going to say out vec2 pass texture chord. Ooh, that's supposed to be a semicolon. And then we need to say pass texture chord is equal to chord. So now, or is equal to texture chord. So now that we have that, we can actually use this in the fragment shader. So we have to say in vec2 pass texture chord. So I'll just do it like this, pass texture chord, and we're going to have the same out color. So instead of using the color from the vertex as the argument, we're going to use these texture coordinates. However, we need one more thing. We need to actually get the image into our shader. We have the texture coords, now we need to get the image. And it's actually really simple. All we need to do is add this one line called uniform sampler 2D, and let's just call it like texture. Or not texture, just use text, because texture is the function we're going to use. So what this is it basically is a pointer to our texture in our program. So what we're going to do when we render it is we're actually going to bind the texture to the active texture, which is 0, because that's how it's going to be like an array of textures, and we're binding one texture that would be in index 0, and so this defaults to 0 because why would you change anything about that? But yeah, so now that we have that, it actually knows where the image is and how to use it. And so now we're going to actually get the color of the images using our texture coordinates. So say that we want the middle of the image, like the middle color, which is, I don't know, blue maybe, I don't know what it is. If we use 0.5 and 0.5, which is our texture coordinates, that means we can get the exact middle, and that will be our out color. And what function does that is going to be called texture, and then we need the image, which is our text image or sampler 2D, and then the texture chord is what color do we want. So pass texture chords, or pass texture chord. And that is it for our shaders. Now, we're going to do something else. If we're going to use color output, then we're going to use like pass color and do some cool blending stuff together. But right now, we're just trying to get the texture onto our rectangle. So the next thing we got to do, there's a lot of steps to this, but the next thing we got to do is we actually got to go into our renderer and bind the texture. Like I said before, we need to bind the texture. So if we go into our render mesh, before we actually bind our shaders, we need to bind the texture. So to do that, we need to set the active texture, which is basically setting the index of our texture array or whatever it's called. So we need to say gl13.gl texture 0. And like I said, it defaults to texture, it defaults to 0. So we are basically putting our texture that we had into the 0 index of the texture buffer, or whatever it's called, like I said. So we need to do gl13, and we need to say gl bind texture, and then the target, which is our 2D texture, so gl texture 2D, and then whatever texture we need to bind, which is our texture into our mesh. Now, before we actually do that, we need to actually get the ability to get a mesh texture, or mesh material is what it's called. So after we define our indices, we're actually going to define a material. So material, we need to store that, which is very fun. So material, private material, and then when you say this dot material is equal to material. And so now what we can do is we actually go into our main program, define what image we want, and turn it and use that as our image. So in our create, we need to actually create the material. So material.create. And then also in our destroy, we need to call material.destroy. So material.destroy. And so now we also need to have a getter for our material, so we can actually get it from our renderer. So public material, get material, return material. So now we actually have the ability to use a material. So yay! Now we can actually bind it. So mesh.getMaterial, get material, and then we need to get the texture ID. So get texture ID. And so with all that done, we still got one more step. We also have to enable the texture coordinates. So GL enable vertex attrib array and disable it after we're done. So GL disable vertex attrib array. So there we go. So that's basically it. Now we have ourselves a way to get textures into it, and yeah. So actually, let's actually run the program, see what we got. Oh, we got error. Where's that error? Oh yeah, forgot to actually implement main. So to do that, like I said, we just need to add another argument called vector 2D. So new vector 2f, and then here we need to actually define the coordinates. So I think this is different from what you've seen before. This is actually counterclockwise. There is a specific way we have to actually define our positions. So we have to do it counterclockwise, which is the opposite way of a clock. So going to the left. So what we need to do is we need to define the top left corner first, which is negative 0.5, 0.5. Then we need to do bottom left, bottom right, and top right. Now, if that's different, just copy these numbers. Uh, if they're not different, then you're good to go. So now, what top left is basically, well, that's 0, 0. Like I said before, when I was explaining texture coordinates, that is 0, 0. So now I'm just going to copy this vector 2D or 2F and just give it to all. And so that should get rid of those errors, or it should be 0. It should have it should be all floats. There we go. So now we also need to define a material for this. So we're just going to say new material, and we're just going to give it whatever image it is. So I'm actually going to go get that image. I'll be right back. Okay, so now I actually got that material copied. I'm just going to actually create a new folder for this. So we're actually going to say resources, and we're going to make a new package, and we're going to call it textures. And then I'm just going to paste the image in here. So paste. So in here now, we should have our texture, which is called beautiful.png. And so let's define that path. So give it a string called textures / beautiful.png. And now we should import material, but we should be able to have a texture onto our little rectangle. Yeah, that's what it's called. Save all that. Make sure there's no more errors. Is that error? It's just slow loading. Okay, let's run it. Okay, so there's a little error right here. It's basically saying that you can't really do anything OpenGL until you initialize OpenGL. The problem is we don't initialize OpenGL until we get our window, and we're actually doing stuff in OpenGL before we actually create the window. So we actually have to make this material, our loading, in our create function. So basically just reorganizing the code to actually make it work. So the problem is we don't have the path variable anymore, so we actually have to define that in our constructor. So private string path, we can just say this dot path is equal to path. So now it shouldn't make that error anymore. Well, just before you actually run that program, you might want to actually define these vector coordinates. So top left is of course 0, 0, but bottom left is going to be 0, 1. Then we have what is this, bottom right, which is going to be both 1, 1. And then finally for the top right, it is going to be 1, 0. So now if you run this, um, it works basically. And there we go. So now we have a texture loaded into our program. But if you're using a bit of a smaller image, this isn't a small image, so it doesn't really matter, but I'm going to show you what a small image looks like. Okay, just paste this into here, and there we go. So this is just called image PNG because I was lazy and I just called it image. And so what this does is it's a bit of a smaller one. It's 64 by 64. And as you can see, it is blurry. So why it's blurry is because of the filter we used in our material class. So right here, when we use GL Linear, what it does is basically tries to make all the colors, try to smooth together, make it all look fine. Now this works for bigger images like the beautiful.png. That's a bit bigger than the normal image. But for small images, as for existence, the Minecraft resource pack images, it wouldn't really work because it'd just make everything a blur and it wouldn't look that good. So if you want to make everything blurry or like try to smooth it together, you would use GL Linear. But if you want to use exact rigid pixels, then you would use GL Nearest, which basically means that it won't interpolate or whatever the word is. Oh, that's not accidentally out of S there when I try to save it. So now it want to interpolate pixels and it should be pretty rigid as you can see. Now I'm just going to use the beautiful picture just to see that it isn't really a big difference if you're using big ones, but for small ones it makes a pretty big difference. Now that is optional, like if you want blurry images, that's fine, but I would not like some blurry images, so I'm just going to keep it pretty rigid. I would get blur if I wanted blurry images, I'd blur them myself, because that's my logic. And so there we go. We have textures loaded onto the rectangle now. So that's it for the tutorial. If you like the tutorial, thank you so much for watching. Please leave a like. Make sure to subscribe if you want to see more tutorials. And I'll see you guys in the next tutorial, which would probably be like matrices or something like that. Anyways, bye.